Hey everyone! Welcome back to Bugnojutsu, where we break down LeetCode problems and explore efficient strategies to solve them. In today's video, we're tackling an easy but very practical problem: maximum number of words you can type, LeetCode 1935. This problem is a great example of string manipulation combined with careful checking of conditions. Even though it's categorized as easy, it's an important stepping stone for beginners to understand how to handle character filtering and iteration in a clean and optimized way. Let's dive into the problem, understand it thoroughly, and then walk through a clear solution. Imagine you're typing on a keyboard where some letter keys are broken. The keyboard works perfectly fine for all the other letters, but the ones listed as broken simply won't work at all. You're given a string of words separated by spaces. This represents the sentence you want to type. You're also given another string, which lists all the distinct broken letters. Your task is to figure out how many words from the sentence you can still fully type without using any of the broken letters. To break it down, if even one letter of a word is broken, you can't type that word. But if none of the letters in a word are broken, then that entire word can be typed successfully. The challenge is to analyze every word in the sentence and count only those that are fully typable. Let's take an example: text equals hello world and broken letters equals add. The sentence contains two words, hello and world. First, check the word hello. None of its letters, H, E, L, L, O, are in the broken set, A, D, so you can type hello without issues. Now check world. This word contains the letter D, which is broken, so you cannot type world at all. Therefore, out of the two words, only one can be typed fully. The final answer here would be 1. This process illustrates that even if just one character in a word is broken, the whole word becomes invalid. To solve this, my approach is straightforward and efficient. First, I split the sentence into individual words using the space as a separator. Then, I treat the string of broken letters as a set or list for easy checking. For each word in the sentence, I go through all the broken letters and check if any of them are present in that word. If I find even one broken letter, I mark that word as invalid and skip counting it. On the other hand, if I don't find any broken letters in the word, I increment my counter because that word is fully typable. This method ensures we check every word carefully but also exit early once we find a broken letter, which saves unnecessary work. It's simple but effective for the constraints of the problem. The time complexity of this approach is n times m, where n is the number of words and m is the average length of the words combined with the number of broken letters. This is because for each word, we may need to check each broken letter. The space complexity is k, where k is the number of broken letters we store in a list or set. Both complexities are efficient for the typical input sizes in LeetCode's constraints. This problem is a great reminder of how basic string operations can be combined with condition checking to solve practical challenges. One key insight here is to short-circuit your checks. As soon as you find a broken letter in a word, there's no need to keep checking that word. Another important takeaway is to consider using sets instead of lists for broken letters to make membership checks faster. Finally, even though this is an easy-level problem, it's a solid exercise in understanding iteration, conditional logic, and performance optimization, all skills that are critical for tackling tougher problems later on. And that's a wrap on LeetCode 1935, maximum number of words you can type. I hope this breakdown gave you a clear understanding of how to approach the problem systematically. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you never miss an update from Bugnojutsu. Share this video with fellow coders who are practicing their problem-solving skills, and drop a comment below telling me how you optimized your own solution. Until next time, keep coding and keep improving. See you in the next video on Bugnojutsu.